Greetings and welcome to today's session. In this video, I'll be taking you through the UNEB Chemistry Paper 3. That is our practical paper for 2025. I'll be taking you through the scoring guide to this paper. And as I told you, this is our last session to UNEB 2025. In the previous sessions, we have gone through UNEB Chemistry Paper 2. We have finished that one for paper 1, and now this is our last session to UNEB 2025, and we shall be going through the chemistry paper 3. On this picture, we can see something about the pure substance, and we know very well that our chemistry paper 3 item, it was about the purity of substances. Let's go through item, the scenario, and then thereafter we shall be going through the scoring guide to this paper. For those who have not yet subscribed to our channel, don't forget to click on that subscription button and also share with friends so they can always benefit from whatever we discuss. Let's go through the scenario as fast as possible. So the scenario says a women's group in Otangusinj village, abbreviated as OWG, wants to make an effective solid insect repellent from some raw materials. Majority of the women are doubtful of the purities of the raw materials bought by one of their members, since some samples did not work as expected. The group is aware that a pure raw material should melt between 78 degrees Celsius and 81 degrees Celsius. In addition, the group has information that cooling curve is the method they can use to determine the purity of their raw materials, but they do not know how it is done. You are provided with solid Z, which is a sample of the raw material submitted by OWG. Task: design an experiment you can carry out based on the method OWG has been informed about in order to advise them on the purity of the raw material. Then in brackets they have said that your design should include the aim, the hypothesis, the variables, apparatus and materials, procedure, risks, and mitigation. I believe by now we are aware that when we talk about design of an experiment, in this case we are looking at the planning phase. This is what any learner, when you get a paper, this is what we start with. Planning, understanding which materials we need to use, understanding the procedures, putting down the table of results, and then thereafter we can carry out the experiment. So that is the planning phase, where we look at the aim, the hypothesis, variables, apparatus, procedure, risk, and mitigation. When you go to the comment section, we have a link which is having the tutorial about explanation on each and every part, especially like aim, hypothesis, variables, explaining what is expected of us. So we can also check on that video in the comment section so that you can be able to follow on how we can always design any aim, hypothesis, or variables for an experiment. Then part B, carry out experiment and record your results. Now in brackets they have put a minimum of 6 recordings required, meaning when they say a minimum, which means the least number of recordings should be 6. So in simple terms, it is 6 greater or equal to 6 recordings. So you can do 6 or more than 6, but not less than 6 recordings. Then finally, part C, they said, analyze your results and inform OWG accordingly. Now, this is our item for paper 3 UNEB 2025. And when you read through this item very well, we see it is an item about the purity of substance. Where do we find this in chemistry? We find this content in Senior 1 work. When you are beginning Senior 1 under experimental chemistry, our second topic in Senior 1, experimental chemistry. That's where we find the criteria of determining purity of substances, and number 1 is by determining their melting point and boiling point. So when you look at this, in the scenario they have stipulated it very well that a pure low material, right here, a pure low material should melt between 78 and 81 degrees Celsius. So our aim in this experiment is to determine whether this substance, solid Z, that they have given us can melt between 78 and 81. If it doesn't, then it will not be the material they need, or it will not be the solid that they need for such an experiment, for making the repellent. So, and when you look at this, in addition, the group has information that cooling curve is the method they can use to determine the purity. So we're going to use the cooling curve method to determine the purity of solid Z. But how do we know that it is pure? If it melts between 78 and 81 degrees Celsius. I believe now we can go to the scoring guide, and we start with task number 1, where we are looking at designing, and that is planning phase to put the aim of experiment, hypothesis, and in this session I'll be taking you through even the scores and some few mistakes that learners make that can make someone lose out some scores when we are responding to such an item. For those who have not yet grabbed this copy, we can order for your copy and we'll be able to deliver wherever you are. We have this for practical competence-based curriculum, that is for paper 2. We also have remedy to chemistry, that is for paper 1. So if you need, maybe your teacher, you need to supply to your learners, or your learner, you need a copy in the box on this number, and we'll be able to deliver to you wherever you are. Okay, let's go direct to our scoring guide, our expected responses. So we are starting with task number 1, where they want us to design the experiment, and we said whatever we're doing here is in the planning phase. This is our planning phase. In our planning phase, that's where we get to know the aim of the experiment. So what is the aim of experiment? From the question we have seen, we are saying that it is to determine the purity of solid Z by plotting its cooling curve and identifying its freezing or melting point. Now, this is a general statement, but in this case, what are they looking for? They just want us to look for the melting point, because in the scenario, they said that the group is aware that a pure low material should melt. So here we're not looking at the freezing. Instead, we're looking at the melting point, which is between 78 and 81. So, meaning, in our aim, we don't need to talk about the freezing. Instead, we can consider only melting. So we say to determine the purity of solid Z by plotting its cooling curve and identifying its melting point for comparison with the specification 78 and to 81 degrees Celsius. When you put that one very well, you get all the 5 scores. Then hypothesis. Hypothesis, we say that this is the prediction that we make. But of course, prediction is based on the clear evidence that you have. So whenever we are carrying out an experiment, we have to be having some theory about what we are going to carry out. So which theory do you know about the cooling curve? Which theory do you know about the determination of purity of different substances? So when you look at this, which prediction could you give? If this substance is pure, what will happen? If it is impure, what will happen? So here in the hypothesis we say that if Z is pure, the cooling curve will show a sharp, nearly horizontal plateau between 78 to 81 degrees Celsius. Then if Z is impure, the plateau will be broader and or shifted outside 78 to 81 degrees Celsius. You recall 78 and 81 is the one which was given to us in the scenario. So this is our prediction, and which means at the end of it all, when you carry out this experiment, we are proving whether this statement is right or whether this one is the right statement. So this is a general statement that we are putting our prediction. So our work is to prove whether the hypothesis is true or not. So when you give such, you get all the 6 scores. And then we go to the variables. Variables, these are things that keep on changing as you carry out the experiment. And we say that they are categorized into 3. Categorized into 3. Number 1, we have the independent, we have the dependent, and we have the controlled variable. We say that the independent variable is also known as the manipulated variable, what we keep on changing. So when you're carrying out our experiment, what are we keeping on changing? What we are changing, we are looking at the change in temperature as time goes on. So that time becomes our independent variable. As time goes on, what are we observing? That one is what we call the respondent variable, or what we call the dependent variable. It is responding to the manipulated variable. So respondent variable, also known as dependent variable, becomes the temperature in degrees Celsius of Z during cooling. So this one gives you 2 scores, and also this one gives you 2 scores. Now, the controlled, also known as constant variable, that variable that you don't change, that substance that you're not changing, that thing that you don't change throughout the experiment, is what we call the controlled variable. So what are we not changing in this experiment? Number 1, we have the mass of Z. The initial temperature keeps the same. Rate of cooling, thermometer position, size, or the type of container. So it has all these, we keep them constant. We don't change them. So those ones are the ones which are giving us the constant variable, or what we are calling the controlled variable. So you get all here, also you get the 6 scores under the variables. Okay, now there's an NB here which I put understanding variables in cooling curve experiment. So when we are talking about the variables in cooling curve experiment, we need to know what a cooling curve is. So we're saying that a cooling curve experiment is a physical measurement experiment, not a comparison test where one factor is deliberately changed. So it's used to observe how temperature changes with time as a substance cools, and from that we deduce the purity. So in cooling curve experiments, those are the key things that you are looking at. What happens to the temperature, how temperature changes as time goes on. That's why we have seen that in time, the time is our independent, while the temperature is our dependent, and then all other things are kept constant. So that is the key thing that we have been looking at, and cooling curve experiment. Then the apparatus and materials that we need. So we needed test tube, we needed 250 cubic centimeter beaker, we have the thermometer, we have the retort stand and clamp, Bunsen burner, spatula. So here we don't put the range, 5 to 8 grams. Which grams have they given you in the paper, or which grams are you using? So it be specific. So we have string or rubber band. Don't put two things. What are you using? What you're using in the experiment is what you put. So all these here you have put Bunsen burner or heat source. It depends which one are you using. So you don't need to put that two. But in our discussion here, we put a variety so that you can always change. You can always change according to what you have in your laboratory. So here we don't put a score, because at the end of it all, these apparatus and materials, you're going to use them in the procedures. So there's no score that you are going to put on that. Let's look at the risks and mitigations. So risks and mitigations, we said, as you're carrying out, before you begin an experiment, we need to identify some of the things that may occur, the accidents that may occur, and then you devise how you're going to manage them. So risk management is a key, especially as we look at this generation. We don't want someone to call out something and doesn't know the repercussion of doing whatever he or she is doing. What could be some of the outcomes or the dangers that may come along when you're carrying out such an experiment. So here we're saying that hot water, you recall there is, or the hot glass, we have some heating, or the breakage of what? So when you talk about breakage, we can maybe breakage of the test tube, and then, or breakage of, because we're using the retort stand, and we are using the test tubes, we are using the glass beaker, breakage of glassware. So we need to be specific when you talk about breakage. Breakage of what? So what do? Clamp apparatus securely, keep the thermometer off the glassware. So all these are mitigations. So here you just need only one and you get all the three scores. Of course, I'm not giving you what to put. Depending on which materials you're using, which apparatus you're using, you can be able to know what to do in that case. So since there is also heating, there could be some fire risks. And what do? Use a water bath for heating and keep flammables away from flame. So, but as we said, only one can be enough. Procedures. Let's look at the procedures. So the language of procedure remains the same. We don't just say add this. Instead, we say 5 grams of solid Z are pressed in a dry test tube, and then a water bath is set up in a 250 cubic centimeter beaker. Then number 2, the thermometer is suspended so the bulb is fully immersed in Z but not touching the glass. Then we have the water bath is heated gently until Z melts completely and its temperature is still above 85 degrees Celsius. Stirring is done gently while melting to ensure uniform heating. Then the heat is removed and stopwatch is started as the temperature is recorded at fixed intervals every 30 seconds. Well, let's remove this. So every 30 seconds as Z cools and is stamped. So here we're saying and is stamped. That's why we're saying do not stir during what? Cooling. So during cooling, we leave it to cool on its own as recorded every after 30 seconds. So readings are continuously read until the temperature is well below 65 degrees Celsius. Then the results are tabulated and the cooling curve plotted. Then the temperature in degrees Celsius against time in seconds or in minutes is plotted. So lastly, we are saying that at any constant temperature plateau or freezing point is identified and compared to that of 78 to 81. So when you put down these procedures very well, you get all the 5 scores. So you can see in the procedures we have also included the materials needed. Then after that, that's when we look at the table of results. So in table of results, we have two variables: the independent variable, which is time in second, and then temperature in degrees Celsius. There's one thing that like here on the results are tabulated and the cooling curve plotted, temperature in degrees Celsius against time. So here you don't put in second or in minute. Which one have you used? For us, we have not used minutes, so we keep only in seconds. So that is one thing I wanted us to be aware of, so that you don't keep on putting two things at the same time. So since we're using seconds, and we said every after 30 seconds, so which means it becomes from 0, it was 85, at 30, 83, okay, at 90, 81. So you see like that, like that, like that. So when you record very well that, you get all the 5 scores. But you get all these scores if here you have put the right units, and even here you have put the right units. So you have to make sure that the units that you are using are clear and also are the ones that you're supposed to be using. Then after that, we can draw the graph. So that is data recording. Then we need the scores for data presentation. Data presentation. And that's when we get the scores, especially for the graph. So a graph of temperature against time, the cooling curve of solid Z. So it is there. The first score I give is time in seconds, temperature in degrees Celsius. So I believe this one we can be able to do, and then we draw a smooth curve. We can be able to draw a smooth curve. Now you recall it was between let me see here. It was between 78 and 81. Between 78 and 81. Say, let's see. 78 and 81, somewhere there. What do you say about when you look at the plateau? Are you seeing between 78 and 81, the plateau is almost straight? Are you seeing that? So we can use our graph to analyze the data. And we say that if between that region, if the plateau is almost straight, then we say that substance is very pure. So, but of course we haven't reached an analysis, but this is something we wanted us to first observe. When we are drawing, we draw a smooth curve. At the end of it all, we'll be able to come and analyze and see whether the substance is pure or not, between the range that it is supposed to melt from. So when you do this, you get all your 5 scores, but of course your scale should be consistent and your labels should be clear. Now when you come to analysis and advice to the OWG. So we are saying that during cooling, a pure substance shows a constant temperature plateau when it freezes because the latent heat is released. Okay. From the results, a clear plateau is observed at approximately 81 degrees Celsius, lasting about 90 to 80 to 180 degrees Celsius. The plateau is almost horizontal. The temperature lies between the expected range. So the freezing range is now about 1 degrees Celsius. These features indicate a pure substance. Are you seeing that? Where are we getting all these? They are saying that the clear plateau is observed at approximately 81 degrees Celsius. We go back to at approximately 81 degrees Celsius. Are you seeing? This is 80 at around 81. You can see it is straight, horizontal line. Maybe if you can use blue, you can be able to see it very well. Between here, you can see a flat horizontal line. So a horizontal plateau is observed at that range, and it is within expected range 78 to 1. So we say that absence is pure. Here you get all the 6 scores. Conclusion. So we're saying that conclusion and advice to OWG, we're saying that the cooling curve of solid Z shows a sharp, nearly constant plateau at around 80 to 81 degrees Celsius, which lies within the accepted purity range of 78 to 81. Therefore, solid Z is pure and is suitable for use in producing the solid insect repellent. And here you get also the 6 scores. The total score, that is 47. 47 for paper 2. That marks the end of our paper. And as I said, this was our last session to Chemistry 2025 UNEB. Those who didn't watch our first sessions for paper 1 and paper 2, please go back to the channel and you look at the previous sessions so that you can be able to follow what we have been discussing in the previous sessions. Some people were asking, how do we get the previous sessions? I'll be able to take you through how we can always access that work, especially for those who missed out paper 1 and paper 2. But before we go there, still a reminder to those who have not yet gotten this practical book. It is very ready with new updates. This one has a new updates. Let's make sure that we grab our copies for paper 2. That is this one for paper 2, and we also have the one for paper 1. I want to remind those who are in senior 4, senior 3, and senior 5. Their online sessions have started already. For those who have not yet registered, we can pick up the form and register as early as possible as we go through the online sessions for this December and January 2026. So for those who want to see the work for first sessions, so you go on your YouTube. When you go on YouTube and you type there Nyirimbibi Isaac. So when you type on YouTube Nyirimbibi Isaac, they'll be able to bring for you this. You click on Nyirimbibi Isaac Chemistry Connect, and then you go to click on videos. So when you click on videos, you can scroll down. You'll be able to see a number of videos that we have already uploaded. You can see we have this UNEB Chemistry Paper 2, Practical 2025 Full Scoring Guide. It is already there. Then we have UNEB Chemistry Paper 1, Section B, Scoring Guide. It is also there. We have Paper 1, Part 1. So this is Paper 1, Part 1, Section B. And then we have Section A, and we also complete. So all the sessions are there on the channel. Let's not forget to always subscribe. You come to the channel, you subscribe and share with friends. Have a blessed time. God bless.